So here we are given the problem to prove that for every tree T, there is a vertex within the vertex set of the tree with the property that this vertex, V, is contained in every maximum length path. So we're first going to consider P1 and P2. We're starting with two maximum length paths that are distinct. And we want to show the following. The vertex set of the first path intersect with the vertex set of the second path is not the empty set. So there is a mutual vertex between these two sets. To show that this claim is true, we can consider that if they have no mutual vertices, this should be equals the empty set, we can note that since T is connected, this is just part of the basic definition of a tree. I used to think it just meant an acyclic graph, but it's an acyclic graph that is connected. Since T is a tree, there will exist a path Q with one end in P1 and one in P2. And then we can just note that in this path Q, we can construct it so that all of the non-end vertices are disjoint from P1 and P2. So all the interior vertices are strictly in Q and are not in either of these. However, we can note that uh, this value here, P1 union Q union P2 is a longer path. So we have a contradiction. Therefore, there must be a vertex in common. Now, the original question said that every maximum length path, not just two. We're using two as an example here, but there could be a set of 15 maximum length paths, whatever. We can just note that for all maximum length paths, and we'll write this down as P1, P2, all the way up to Pn, we can apply the same logic for every ij where I does not equal j and 1 is less than or equal to ij, which is less than or equal to. So we're just saying here that even though we showed in the above example, just for P1 and P2, we can apply the same logic to any sort of value as long as these sets are distinct. And doing that is sufficient, so we are done the proof.